Thank you, everybody, for coming. Today, we're going to be talking about tuning Tableau Server with an emphasis on performance best practices. My name is Jonathan, and this is my co-presenter, Sid. So the question we want to answer here today is based on the quote behind me that I've heard a number of times working on performance cases, and maybe you've said to yourself after coming in one day. Sometimes we come in, and suddenly performance has changed, usually for the worse, and we tell ourselves that nothing happened, we didn't change anything. But often the causes aren't in our control or aren't something that we natively have insight to. So today we want to review the tools that will help give you insight into what is causing your performance issues, tracking when and how severely they're happening, and of course we're going to give you some pointers on what you can actually do about it to make your performance better. So my name is Jonathan Berkowitz, and I've been with the Tableau development team since 2012. So it's actually been a pretty long time in Tableau terms. To give you an idea of how long that is, when I joined Tableau, we shipped two new and exciting features that you all are familiar with today. Filled maps and having a data server to have published data sources too. Thank you. But just imagine, for those of you who maybe have always had those features, what would Tableau have been like without it? That's a long time ago. So some people, they call me a little bit of a Tableau dinosaur. After being with Tableau in the Seattle home office for 5 years, I actually moved to DC 2 years ago, and I've been based out on the East Coast. Outside of work, I enjoy hiking pretty much anywhere I go for vacation, even down here in the Southwest in the heat. I like dabbling in photography, and I'm on a sailboat racing team out of Annapolis now that I'm on the East Coast. So if anyone wants to talk about sailing after the session, please come up during the Q&A, and I'd love to talk about it.
Thanks, JV. I am Siddharth Luthi. I am a software engineer at Tableau. I joined in 2017, and my main role is dealing with customer performance cases. I've been spending the last 2 years trying to work myself out of a job. You heard that right, working myself out of a job. And the only way I can do that is if you guys don't run into any performance issues. So hopefully the session today, oh, thank you. Hopefully the session today will give you the tools and techniques that you can use to solve your performance issues. I graduated from Arizona State University. I love sports. And looking forward to talk to you all today and answer your questions around performance. I hand it back over to JV.
Thanks, Sid. So we've introduced ourselves a bit to you, and I want to get a feel for who's here with us today and what kind of roles do you host. So we're going to do a hand-raising activity, get our heart rate up, get ready for data night out. I really like hand-raising activities. There are going to be a few of them through the hour, so be prepared. So I want to learn about who you are. So raise your hand as I go through each of these bullets if they apply to you. Is anyone out there, are you a power user for Tableau, making some awesome dashboards? Awesome. I see a lot of hands and more going. Excellent. Is anyone out there a Tableau admin of some sort? I think I see every hand up, which is what I would expect in a session about adminning Tableau Server. Is anyone out there also play a role as an IT admin setting up hardware? A nice mix of hands. And now for the final group. Is anyone out there a business leader? I see a few hands. We're very glad you're here. We hope that you can take away some lessons and you can see how to deploy server a bit better. So now, of these groups, there's another interesting question. Raise your hand if you were more than one of the above. See a couple of hands. Now keep your hands up if you were all of the above. I see one hand in the back, maybe another one over there. So in the important lesson, aside from for you two, is that the tools and methodologies we're going to talk about here today aren't something that you alone can do. These are lessons you're going to want to take back to your organizations and find and work with the other people at your companies or your organizations to execute on. So I want to briefly go over the agenda, and then we're going to get started. So we're going to start at some system-level monitoring tools, really the basics. How do we get onto a computer, look at what resources are being used, how do we save that information to get historical data. Next, we're going to talk about tools that we at Tableau created specifically for monitoring Tableau. And after we've monitored and tracked issues, now that we see what's going on, what are the knobs we can turn to make improvements? Because I think you came here to learn how to make performance better, not just see how it's doing. At the end, we're going to have a little bit of time for Q&A, and we're going to invite anyone with questions to come up and talk with Sid and I at the end of the session. So write down any questions you have, and we'll be glad to chat. So let's dive in on these tools of the trade for monitoring. So to start, we're going to start pretty high level. We're going to start with Perfmon. Anyone out there used Perfmon before? Familiar with it? See a smattering of hands, excellent. So it's kind of like System Monitor, Control-Alt-Delete that we're used to, but it's more powerful. So it's available on all Windows machines that are going to be out there, but there are hundreds of metrics. You can configure which of these hundreds of metrics are you interested in: CPU utilization, disk monitoring, disk queuing, anything you want to your heart's desire, you can put it and you can record in a visualization. It's very configurable, not just in what you record, but what frequency are you saving. You can even have a circular buffer running and only output information to disk when some trigger is met. Now, it's also easy to save and share those files. If you're working with support, something like this could be very helpful to them when diagnosing your problem. For those of you on Linux out there, there's the System Activity Reporter, pardon me. It's a Linux tool with very similar functionality that you can use. Now, in case anyone out there isn't sure if it's on their Windows machine, I've got good news. It was first sent by Windows in 2006. And if you haven't updated your OS since 2006, there's some separate issues that we may want to address beyond the scope of this talk. And 2006 was quite a long time ago and was an important year. It was the year that the International Astronomical Union kicked Pluto out of our solar system. Also the year I canceled my subscription to their newsletter. I was not a fan of that decision. All right, let's dive into the first of the Tableau tools that we created for you to monitor Tableau. So there's a tool called Tabon that was created by Tableau for Tableau monitoring specifically. It utilizes perfmon under the hood. So for those of you already familiar with perfmon, this is going to feel very comfortable and native. And for those of you who just learned about perfmon, all of those benefits I just talked about are bundled into Tabon. Unlike perfmon, which can only run on a single machine at a time, Tabon can be distributed across all of the nodes that you're running server on. How many people have multiple nodes in their server deployment? I'd say about half the hands I see up. So if you have multiple nodes, having to run a monitoring service on each node and then checking each node for performance, it's kind of a headache. But with Tabon, it's all saved to a single Postgres database. Now, we also built in some additional hooks into Tableau so you can correlate any of those system events to events happening in Tableau Server. So you can see if a backgrounder job getting kicked off or viz being loaded is causing that spike. And for those of you who are interested in learning more about Tabon, trying it out, there's a QR code behind me. Just scan it with your camera phones and you can get linked to the documentation to get started. If you can't scan it now, all of the QR codes that are in our deck today, there's a secret hidden slide at the end with all the URLs. The entire deck is provided to you after conference and you can get them from there. So don't worry if you can't grab it now. Next, I'm going to hand it over to Sid to talk about Logshark. This is actually, and frankly, one of my favorite tools from all of my years working here at Tableau.
Thanks, JV. So I'm going to be talking a little bit about Logshark today. So raise of hands for people who have heard of Logshark or used Logshark before. All right, I see quite a few hands here. So that's great. For those of you that have used Logshark before, I'll be talking about some new improved capabilities that we just released in a new version that was released just a few days ago. For those of you that haven't used Logshark before, I'll be doing a short introduction on what Logshark is, what it does, and how you could potentially start using it to troubleshoot performance issues with Tableau Server. And pro tip, this is one of the tools that we first use internally whenever we get performance cases from customers. So a lot of the stuff that I'm going to be talking about here is exactly the stuff that we end up doing when we get a performance case. So what is Logshark? You can think of Logshark as a tool that gives you operational insight into Tableau Server. What it essentially does is it takes logs as input, it parses the logs, and it produces Tableau workbooks as output. Now, what kind of Tableau workbooks does it produce? A variety of workbooks that give you insight into what is happening on your Tableau Server installation. The different kinds of insight that you can get are what are the most frequently loaded views and workbooks on your server, what your backgrounder jobs are doing, if they're getting delayed or if they're getting stuck. You can get detailed insight into each individual user action, and I'll be talking about that a little bit more in the upcoming demo. I mentioned that we had a new version that we released. We just released a new version a few days ago, and it has some significant performance improvements. When I say performance improvements, I am not talking about a 10 to 15% improvement in performance. We have seen at least a 10 to 15 times improvement in performance. So your Logshark runs, thank you, your Logshark runs are going to be super fast. you're going to get the results that you're looking for today. We have already started using a lot of this tooling internally, and the results are just fantastic. Logshark, as you know or may not know, is a freely available tool that you can download from GitHub. It's a community-supported tool. Anybody can go and download it and start using it today. There are links to the download that we have later that you will be able to use to go and access the tool. The other new thing that we released with this new Logshark version is a new and improved version of the activity and resource tracing workbook. So what is activity and resource tracing? Activity and resource tracing is a new framework that we introduced a few releases ago that provides detailed information on elapsed times, CPU consumption, and memory consumption for each activity that gets triggered in response to a user action. So for example, when a user performs an action to load a view, there's a lot of stuff that goes on behind the scenes. And activity and resource tracing can give you that insight into what exactly is happening, what are the resources that are being consumed, and how much time is being taken up by each component that then ends up giving you the view load that you're looking for. So what are some of the different vizzes that we are providing as part of this new activity and resource tracing workbook that we released with Logshark? Some of the main questions that we have seen Tableau Server admins or Tableau Server users and even ourselves asking internally for our Tableau Server installation are, I loaded a certain view. It was very fast yesterday, but it's slow today. And what's going on? Why is it slower today and why was it fast yesterday? The other question that we keep asking is, do I need to talk to my DBA about how my queries are performing? Are there certain queries that are faster at certain times during the day and then they're much slower at other times? Have you had questions around, I wish I could find out which workbooks on my Tableau server are the most resource intensive when it comes to consuming RAM or CPU? That would be pretty good information to have, because that will give you insight into what are the workbooks that are consuming the most resources. And what about users complaining of them running into errors with Tableau Server? You have users coming up to you and saying, hey, so I tried to perform these actions and all I got was an error and I couldn't do what I was looking for. So what can you do to actually drill down into that particular user action and find out why the error happened? Was that error a pattern? Were there other users that were seeing the similar error? Or was it limited to a single workbook or a view load? So those are the kinds of questions that we are hoping this new activity and resource tracing workbook is going to help you answer. And I'll be doing a detailed deep dive into the workbook through a demo today. And I'll also be explaining a few things via slides. Specifically, one concept that I wanted to talk about a little bit more was this concept of flame charts. And some of this content is going to be like a detailed deep dive. And don't worry, there is a lot of documentation that we have already uploaded to the website that talks about all of this stuff in great detail. So you don't need to take notes or memorize or do anything like that right now. We have everything uploaded onto the website that you can view and reference later. So what I wanted to talk about was one of the most interesting views that we were able to build with the activity and resource tracing framework was a flame chart view. What you're seeing here is a single user action. And this pretty much gives you a list of all of the activities that happened during that user action. You can think of this as an X-ray view into the user action. Each bar up on the screen there corresponds to a single activity. The length of the bar is proportional to the elapsed time for that activity. The bars that you see higher up on the screen are the parent bars. The ones that are lower down are the child activities that were spawned by the parent activities. So that's, in a nutshell, what a flame chart view should look like. The y-axis here corresponds to the depth. As you go down the flame chart, the depth level increases. The x-axis corresponds to the timestamp of when the activity started. And I'll get into a lot more details around these flame charts. But one thing that we have found very appealing with the flame chart is, in a single click, you can visually identify long-running activities. So whenever you see bars that are very long, you're going to immediately ask the question, okay, so that's something that I see that's taking a long time. Let me find out what that thing is and why it's taking a long time. Next, I'm going to jump into a Logshark demo where I'm going to demo all of the different views that are available as part of this activity and resource tracing workbook. And you'll see why I am so excited about the fact that it's now available for everybody to use. So this is the first of the views that I'm going to show. I spoke about flame charts in the previous slide. What you're seeing here basically is a plot graph where each dot on that graph represents a single user action. So every dot there represents a single user action. And all of these dashboards have been created by parsing the logs that are generated by Tableau Server. Each mark there represents a single user action. And you can click on the mark, and a single click will get you the flame chart view that I previously demonstrated. So you can see that I'm hovering over this mark here, and I'm going to click on it, and voila, there is your single flame chart view. Now this flame chart here is showing you coloring. It's a spectrum-based coloring, where the green bars are the ones that were not consuming as much CPU, and the red bars are the activities that were consuming a lot of CPU. So it's slightly different from the flame chart that I showed you in the previous picture, but this is one of the views that you have available to get insight into which particular activity was CPU intensive. Now you could switch this to the component-based flame chart that I showed earlier by simply clicking on this radio button here. I'm going to zoom in real quick to show you. So there is this component flame chart button that if you click, you will be able to switch the flame chart into this component-based view that I showed earlier. If you scroll down on the flame chart, you're going to see all of the activities that took a large amount of time to execute. You see the longest bar there at the bottom, the one colored in the light green. That actually corresponds to the query time. So that's the amount of time that was spent executing the query on the database side. So you can quickly get insight into this one user action taking a long time, and you can say that, okay, so a large percentage of that time was actually spent executing the query. So if I want to make this user action faster, I need to look at what kind of queries I'm issuing and whether I can do something from the query side to make things faster. So that's just one example of how a single click can help you identify long-running activities visually and then help you drill deeper into what you can do to make them faster. And we're going to have time for Q&A later, so if you guys have questions, just hold on to them. I'll be more than happy to answer all of them at the end of the session. The next view that I'm going to talk about is this compare sessions viz or view. So remember the question that I said that your user comes to you and complains that one particular user action was much faster yesterday, but why is it slow today? So that's when you can actually come to this view, filter it down to the particular user that made the complaint, filter it down to the particular workbook and view that was in question, and all of the marks that you're seeing up on the screen here, the dots in the plot graph, are each user action performed by that user corresponding to that workbook. So you've now filtered it down to the user actions that the user was complaining about. And the cool thing that you can do here is you can select two of these marks. So I am going to go and select this mark and go and select this other one right here. And there is this comparison button that shows up. And I can zoom in here, and you see this session comparison button, this session comparison URL. You click on it, and this is going to now trigger the session comparison for those two sessions. The view that I'm showing here is basically the cache hit comparison across those two user actions. So this session comparison is going to immediately tell you whether one user action resulted in more cache hits as compared to the other, because that would clearly indicate why it was faster. So just one of the things that you can do in this comparison is get visibility into, was there performance variability due to just the caches not being warmed up? And once the caches got warmed up, things started speeding up. So that's good information to have. In line with some of the other radio buttons that we had on the other viz, we have similar radio buttons here. You could click on the elapsed time radio button, and get a similar comparison of the specific activities that were different when it comes to elapsed times. So on the left-hand side here, you can see the familiar flame charts that I described earlier. We love the flame charts if you haven't realized that yet. So the flame charts are lined up one below the other to give you a nice visual comparison of the two requests. And the specific activities that were slower in one request as compared to the other are on the right-hand side view that you see there. And you can hover over some of these and you can see how the highlight action in Tableau quickly helps you visually locate those activities in the flame chart. So this is just a lot of nice little tooling that's available to get more insight into what was different between the two user actions. The next one, intermittent slow queries. This is a very interesting one where we have seen several instances where user complaints of variable view load performance has been due to the same query taking a longer time at certain points in time. And users just don't have that knowledge to be able to go talk to their DBA about this variability in performance. But with this new workbook, you can now drill into whether a single query was taking much longer at certain points in time and the same query was running much faster at another point in time. So again, all of the marks that you see on the bottom view there are the same query getting executed. So I've filtered this down to a single query being executed on Tableau Server. And you can see based on this plot graph that same query was showing varying performance in the beginning. And then after that, it kind of nicely stabilized to performing much faster. So the y-axis there on this plot graph is the elapsed time. The marks that are showing up higher are the ones that are taking more time. The ones that are lower are the ones that are running faster. So now you can see that there is this particular query that had performance that was all over the place in the beginning and then stabilized nicely later. You can get this insight into all of the queries that are being executed on Tableau Server. If that same query was getting executed multiple times, this will tell you whether that query was taking a different amount of time every time it got executed, which is pretty cool. There is some color encoding that we have here that I'd like to talk about a little bit. So the yellow color encoding and the red color encoding is trying to denote instances where, say, the fastest execution time for a particular query was 1 second. That was the fastest time it took to execute. But the same query ran a few hours later, and it took 5 seconds to execute. So that is more than 5 times the fastest time of execution. So we highlight that instance as red. So if you see a lot of reds for a particular query, you know that that query is taking more than a certain amount of time to execute in many instances. So that's kind of our way of getting insight into whether there is queries that are showing variable performance on Tableau Server. And this is one of my favorite charts here, the resource-intensive user actions plot. So if you have user actions on server or specific workbooks on server that are resource-intensive, this view is going to tell you that. The y-axis here is the memory consumption. X-axis corresponds to the CPU time. So all of the marks there, any marks that you see towards the right top of your screen are the user actions that were heavy on CPU and that were heavy on memory. All of the user actions colored with the same color correspond to the same workbook view combination. So right off the bat, you can see that there is one particular combination of workbook and view that is taking up a lot of resources. So you can hover over it and it will give you insight into what workbook and view was taking up the most resources. You can click on it, and in one click, you get information on which particular aspects were heavy on CPU and which ones were heavy on memory. The graph on the left-hand side tells you the activities that were heavy on CPU. The ones on the right tells you the ones that were heavy on memory. So that pretty much summarizes what I'd like to cover during the detailed Logshark demo. All of these vizzes and views are documented in the online documentation that we just released. So all of the details are going to be available there. Sorry. They're all available freely for download. The workbook is available, it's online, so you can download it today and use the faster Logshark to run against your Tableau Server logs and get all of the insight that I spoke about today. It's all available right now. You can just go online and download it. Sorry? A Linux version? So this would work with a, you need a Windows machine to actually run Logshark, but the actual logs can be from a Tableau Server Linux installation. So there's no restrictions to using it on Tableau Server Linux logs. Sorry, the question was around whether it would work for Tableau Server on Linux, and yes, it would. Right. So I'll make a note of that, and I'll talk to you after the session around that. Oh, you know. Okay. Oh, the installation workflow of Logshark. Yeah. Okay. I'd certainly. I can talk about it. I think we can even put in some updated documentation on there if that's going to help users around it, and I'll do that so that all of you can benefit from it. But that's good feedback. Thank you. The next thing that I'm going to talk about briefly. Is the performance recording feature. Now, you guys probably have heard and used the performance recording already, but one thing that I'd like to point out is that there is a new and improved version of the performance recording, like a more detailed version that we are going to be releasing soon, and I'll briefly touch upon that in this conversation. So what is the performance recording? For those that haven't used it, it's a pretty cool feature that allows you to record performance of a certain set of scenarios. The cool thing about it is that it's built into the product, so there's no separate installation required. It's just available as part of Tableau Desktop and Tableau Server. There is a user-triggered start and stop mechanism. So the user clicks the start button, runs through his scenario, and clicks the stop button, and a nice little performance recording, which is a Tableau workbook, shows up, and that'll give you insight into exactly what actions were performed during the recording. The output is a Tableau workbook, like I said. We love Tableau, so we end up using it for analyzing a lot of the issues that we see. It's easy to package up and send. In fact, it's one of the most frequently requested artifacts whenever we run into customer performance issues. Many a times we end up requesting a performance recording of the scenario from the customer. Here's a snapshot of the performance recording. There's various different aspects available here. There is a timeline view. We provide detailed information on the events, and even the SQL query text for the queries that were being issued when you carried out that scenario. The new detailed view that I was talking about, this is a snapshot of the new detailed view that is going to be available in an upcoming release. What we did there was there were many hidden fields and metrics that we were not exposing. We built views on top of those metrics so that the users can get even more insight into what is going on when they do a performance recording. Again, the documentation for all of this will be available when the feature gets released, but we are pretty excited about this feature, about the detailed performance recording view, and we're hoping that you guys would be able to get more information from your performance recordings with this feature. That brings me to the end of my demo. I'd like to hand it over to JV to summarize the tools of the trade and take it further.
Thank you very much, Sid. So, as we saw, we started off with some tools for how we measure and record things, starting with Perfmon. Next, we briefly touch on Tabon for measuring system resources across all of our nodes and reporting it in one place. Next, Sid showed us a demo of Logshark and all the ways that we can use it to investigate all of the activities happening on our server, the performance behind them, how long they're taking, and the resources that they use. And at the end, Sid showed us the performance recording for when we're looking at a single workbook and we want to pinpoint performance issues within that workbook. Before I actually continue, I just want to say that I really love Logshark. As an engineer at Tableau investigating performance cases, it was a game changer. And I was on the team when we were first developing it about 4 years ago, and the timeline for developing it was actually going to be about 9 months for the very first version, and that was too long for me. And I wanted the functionality, so I went out on my own. I wrote a very simple Python script that ran on my computer that could generate some of these images at a very basic level, and to at least honor my team, I did call it Logfish, and it worked. It was not performant, but it got the job done. And now we have this tool, Logshark V4, that just came out, which is just an outstanding tool. All of these things, it's been a lot to take in. I saw a lot of people taking notes, taking pictures. So before we move on, I just want to give us a little break and just take a moment for ourselves. So I want us to center ourselves before we move on. So let us close our eyes and close our browsers. I want you to populate your caches, and I want you to breathe out. I want you to allocate your cores, and I want you to breathe out. And I want you to reserve some RAM, I want you to breathe out. Now, let's open our eyes, and together we can discuss what can we do about it. In the first half of our session, we discussed how to detect and pinpoint what the performance issues are. And while that's great, we want to know what we can do about it. So with Tableau, and as administrators, there's a whole host of knobs that we can turn. So here's a quick overview of the topics I'm going to be going through. And let's go ahead and strap into our control module here and take a look at that control panel behind us. Now, that control panel actually, it looks a bit dated. I want something a little bit more modern. And at Devs on Stage today, we saw a lot of exciting new features. So let's do things in a more modern way. And what better than taking out our tablet, navigating to our admin controls and changing some settings. And I actually have a picture that was taken to me at a customer recently where I was on that tablet making things better. And here you can see me working hard, and the server in the other room, it's looking A-okay. So that's what we want to see, and that's where I'm going to help you get by the end of this session. So let's go ahead and first talk about workbook design. You might be thinking, I'm an admin, though I saw there were some power users out there, and you might be thinking, workbook performance isn't maybe what I'm here for, but workbook performance can have a massive impact on how things go on server. So some things you may want to consider is reducing the number of filters. Obviously, filters are needed. We want to have those on our workbook, but they add complexity both for loading the workbook, but also the queries that get sent to our database. You want to consider how many marks are really relevant. A modern screen that we might have in our offices has 5 million pixels. A single mark, say one of the circles in Sid's examples, that's a couple of hundred pixels. How many of those can you really have all at once and still be relevant? That's something to consider because we still have to render all of them. So think at what level should you aggregate so things are still useful and informative. You want to avoid also having massive crosstabs, so tabular data. And I'm not saying don't do it, but I have an example from a performance investigation that a customer showed us their workbook. It had a number of filters on the top, and they had 8 columns. It seems reasonable. I mean, we could all read a table with 8 columns. And at first, nothing seemed wrong until I realized they had 4 million rows that were shown on the default view of this workbook. So if you think of every cell of a table roughly being a word or a number, some sort of string, that's 4 million strings. But if you look at the Lord of the Rings trilogy, the entire series, that's 450,000 words. Well, they had 40 million words being rendered every time they opened their view. I don't want to judge or assume, but I don't know if you can read that many words before lunch, so you might want to consider what does the default view look like when you open that workbook. Maybe you can have it filtered down so you're not rendering and querying for unnecessary data. And of course, you want to optimize any of the popular workbooks you see. So using Logshark, you can see what's that most popular content on your server that's being loaded. One, I think I've seen at every customer, and we'll do another quick show of hands, whose business has a quarterly sales dashboard or an annual sales dashboard? See a number of hands. All of our salespeople want to see how they're doing at the end of quarter. If you can shave a second off of the load time of that dashboard, and it's loaded thousands of times a day, that's a huge impact on CPU time for your server. Now, if you want to learn more, there's a dedicated session at Tableau Conference called Designing Efficient Workbooks. And if you want to read the white paper, go ahead and scan that QR code behind me. Next, I want to move on and talk about database design. So again, still outside of Tableau. So the first step is go talk to your neighborhood DBA. I promise you that they're friendly and they're going to want to help you so that your two products can work well together. Be sure to work with them, index any relevant fields in your database that are used in your vizzes. Now, when you're doing data source filters, consider reducing columns. So there's 2 reasons here. For certain data sources, Tableau has to send metadata requests for each column. And if you're not going to be using those columns, why spend the time sending the request? But additionally, we're reducing the size of data that has to be returned and sent over the wire back to server for each view load. Also run a data source filter to cut out data that's not relevant. Again, using that quarterly sales dashboard example, let's say you have a decade of sales information for your business. You don't need any of that for the quarterly sales. You just need to know what's been sold in the last several months. So by putting a data source filter on, you can see the yellow square behind me. That's been really reduced. And so smallest amount of information is coming to Tableau that then has to be processed to make your visualization. You can also materialize tables. In the most extreme example, say the dashboard that loads on your CEO's tablet in the morning, you can have a materialized table with one row in the database for every mark in the viz, and that thing's going to load smooth as butter. Of course, now that we've talked about data sources, let's talk about extracting that data. The first and obvious advantage, we've localized that onto our server. It's in a format that Tableau created. It's optimized for us to work with, so it's going to be as fast as possible. You only keep the data you care about. Those filters you applied, those filters we applied before, they're also working on the extract, and we only have on disk the data that we care about. You're reducing load on your live data source, again, with a popular dashboard being loaded many, many times an hour. With the extract, you only run that query once per refresh, and then all of the vizzes will load off of that. You can also hide any rows or fields even after the fact. And you can also materialize calcs. So especially, think string calculations, nested calculations, those can be expensive. And better to have that happen on the backgrounder while your extract is being created than while the viz is loading and one of your coworkers is sitting and waiting for their viz to load. So all these advantages really make a compelling argument to use and optimize extracts. The next area I want to talk about is something that really we can touch on as Tableau admins, which is the topology of our server. So first, you want to keep your workers local to each other. Earlier, I asked who had multiple nodes, and I saw about half of the hands. And in a high level, we recommend keeping them on the same subnet. That keeps latency down. But I want to tell a story from my years working in Sid's role before I became a product manager. It was a customer based on the East Coast, not far actually from where I live now. And they had a multi-node deployment, and viz loads were slow about 1/4 of the time. They didn't know what was going on. And I actually used Logshark, probably V1 at the time. And I ran their logs, and I noticed all of the loads were slow on worker 2. That was an odd problem. I assumed something was wrong with the machine. I don't know if that's what you all thought as well. Maybe the disk is bad. Maybe there's an issue with the network controller. Spent several days investigating with their IT team. And then finally, during an offhand conversation, I realized what the problem was. It was nothing with the machine. The machine was great. Worker 2 was in the Netherlands. This was an international company, and they had provisioned a machine in their network. And it was, unfortunately, not near their headquarters, but one of their satellite offices. We were able to move the machine. It was configured as a VM. Everything got good. So while think about subnets, also consider literally where are the boxes that are hosting your VMs. The first tip we also give for those of you who are on single node now and are maybe considering moving on is to isolate our backgrounders. So this means taking the backgrounder processes off of that worker and putting them on another machine. The reason here is, especially if you're running extracts through the day, that can consume CPU and memory. We're creating those extracts, but that can compete for the same resources that's rendering a viz for somebody trying to look at one of your visualizations. And so you don't want those competing. You can move the backgrounders to the other machine, and even if there's some latency on that other machine because of that, having all the backgrounders in one place, I actually really prefer that. I would rather see an extract finish 30 seconds later than having a coworker of mine have to watch the viz load for an extra 30 seconds. I don't know what you prefer. I know for myself what I like to see. Another thing that's important is with VizQL processes, you want to have 4 cores per VizQL process on any nodes that you have that. For those of you not familiar with VizQL, this is a lot of the heavy computational lifting that happens in Tableau to generate your vizzes and serve that to you. So you want to make sure there's adequate CPU to handle that. The other thing is actually the inverse. I've been talking about adding things. And now with cache servers, I just want to say that more is not always better. People often, you want more caching. I want more caching. I'm assuming other people here do. But when you add 16 cache servers to a machine, which I've seen, you're actually just duplicating your cache content many, many times. And that's not making anything better for you. So what you're better off doing is there's some deeper settings in your documentation where you can expand the size of the cache or make the time that the cache times out be longer so that any content in there will stay there and future viz loads can benefit from that. So in that case, you want to be configuring the size, not the number of cache servers. All right, next I want to talk a little bit about VM resources. Can I see, again, a show of hands? Who's using VMs to host Tableau Server? I expected to see half, and I think I see more than half of the hands up. So first of all, that is awesome. We'd work with VM vendors. Often we run Tableau Server on VMs internally. That's totally a great way to be running Tableau, but there are some special considerations. So the first one to remember is that Tableau can be computationally heavy, as an application. Sometimes it doesn't seem that way. We're just loading pictures, right? But we're creating extracts. We're rendering the images from scratch. That's a lot of work. So to support that, you want to make sure that you're reserving the CPU and memory on your VMs so that the resources are available to do the work. Now, VMware actually recommends 100% reservation for these resources on computationally heavy applications. And I just want to clarify, reserving doesn't mean that you're not going to let other applications run on your VM hosts. That's the point of VMs, and we don't want to look past that. But it does mean that on the machines where Tableau has this reservation, Tableau is going to get first choice of those resources so that when a user is waiting for a viz to load and it's rendering, they're going to see it right away. Now again, if you're interested in learning more about VM settings, here's a great white paper that VMware provided that's talking about deploying computationally heavy applications on their system. So I still see some cameras up. I'll let you get pictures. And again, for those of you who don't have a camera, don't worry. At the end of the slide, end of the deck, all of these URLs are going to be available. All right. I actually want to show an example, though, to help give you more compelling reasons of why this is really important. And we did an experiment at Tableau to see how resource allocation affected throughput on our servers. So throughput being how many vizzes could we render per unit time. And so we had a VM host with 2 VMs, one running some heavy hardware test applications, just using up as much resources as it could. The other VM had Tableau Server running our performance tests. We started with 0% reservation, and we slowly stepped it up over time. And we tried to see, how did we change the amount of throughput? Is there an inflection point? What's the best setting to have? So I've got some sample data behind me for what we think might be happening. And we're going to do a show of hands activity. We're going to do some voting. So who thinks the top left with that nice linear slope, as we increase reservation, we got more? I don't see any hands. Excellent. How about the top right, where we have that nice sloping curve where slowly over time it increased, but really as we got near the end, we saw the most increase? See a few hands? All right. How about the option on the bottom left, that nice S-curve shape where things grow slowly and there was an inflection? All right, I see some more hands. And how about that last option on the bottom right, where throughput just never changed no matter how much CPU we reserved? I don't see any hands up, but I'm guessing we all wish that that was how VMs worked. I think we can agree that'd be pretty awesome. So I want to share with you the results of that test. So again, this was real tests on a real VM, and the results came out a lot like this. So to those of you who voted for the third choice of the S-curve, excellent job. So I want to call out something beyond just the importance that there's this S-curve pattern. Look at the left. We're actually, when we had no reservation and we were equally fighting with the other VM for resources, we weren't even getting half of the throughput. We actually got, it's like 34%, so we only got 1/3 the throughput, because every time the resources were changing hands, there was context switching, the CPUs had to change out their caches, and it was really expensive. So the important thing here isn't just that the more reservation you have, the higher throughput, but by having none, you're beyond cutting your performance in half. So it's a really big difference. The next topic I want to talk about is antivirus software. I'm going to guess we all have it. I know we have it at Tableau. It runs on our machines. But it can be a really big impacting factor for Tableau Server. So it can be a performance sink. It shows up in a lot of our customer cases. I specialize in looking into performance issues on customer servers. And AV came up a large fraction of the time, and it was almost one of my first questions before I learned anything else was, what's your AV situation like? Now, this most commonly shows up as active scans, but also as filter drivers that are running on the OS, scanning every file before it's loaded. You can do things like setting up exclusions or scheduling. I'll be talking through a little bit of the details here later about what you can do and how that helps. So the first issue is, how do we detect it, assuming we don't know it's running? Sometimes, again, as Tableau admins, we don't know what is on the hardware necessarily running in the background. It's beyond our control, and that's how our corporate policies are designed. So first, you're going to see your performance issues being intermittent and sporadic. It might even seem like there's no pattern. It's not always the same time of day, but you see the patterns. They're very distinct, and then they go away. In these, you see unexplained CPU spikes, not correlating to any activity on the server, so what could be causing it? And if you're looking at active and passive scanning situations, so kind of a classic antivirus, you're going to want to use Procmon, the Windows utility, and just see if it's running at that time, how much resources is it using, and pinpoint that to go work with IT. Now, for filter drivers, those can be a little bit harder to see. So you want to use the Windows Performance Recorder, which is a Microsoft tool that really lets you to dig in and see kind of a flame chart view of what's happening when, and if something's so, you'll see that filter driver holding things up in the flame chart. Now, of course, again, what do we do to remediate this issue? That's obviously what we want to do. So befriend your IT admins like your DBAs, because you're going to need to work with them because the policies they are implementing get pushed down to all of our machines. If you have active scans, pick a time thoughtfully. You can actually use Logshark to help do this. With Logshark, you can see when were user activities happening, what times were popular on the server. Honestly, 2 a.m. is a pretty good choice. Generally, most of our coworkers aren't in. But if you have a company that works across multiple geos, it can be a bit more complicated. But Logshark can pinpoint the time that's best to be running these scans. If you can exclude Tableau and Windows directories, that has a really big impact on, especially with filter drivers, having the delays when the Tableau files need to run to load your visits. If you want to read a great white paper on our recommendations about how to run with AV but still keep performance high, again, please scan the code behind me. I'm going to leave it up there for a second. I see cameras still up, still a few. All right. So now I want to give you a couple of parting thoughts before we all leave here. So you have to be able to detect it before you can do anything about it. Kind of obvious, but that's why we showed you those tools before, and I really encourage you to try them out. Then just remember, Tableau's doing a lot of work in the background. Again, we see the nice visualization at the end, but getting there can be a lot of work, be it queries or rendering. Logshark is just awesome. I think it's worth its own point, even though it was just one of the tools. It's so great. And then, importantly, that Tableau can be tuned, and of course, that you can tune your environment. It's not just things in Tableau, but it could be your corporate policy that you need to work through with a business leader, or with IT on how your system is deployed. So I hope that you can take these ideas back to your organizations, share them with your teams, and improve your performance. Now, Sid and I would like to thank you for coming here so much. We're glad to see you. We hope you all have fun at Data Night Out tonight. Is anyone else going? Just me? Okay, everyone's hands went up. Excellent. So please rate our content here today on the app. We'd love to get your feedback to change and improve our session in the future. And we just want to say thank you. If anyone has questions at this time, please come on up and ask them, and we'd love to chat with you for a little bit. Thank you so much.